Hello and welcome to this video tutorial on the Claritas Velocity application CVA. The CVA application can be found on the Velocity tab of the launcher. If I click on the CVA button, you'll see a parameter form will launch. We're required to supply a stacked data set, and we basically drive a lot of the interactivity and location of velocities off the stack data set. These days we don't require a stack, so basically what we'll do is take the input gathers, which can be shot or CDP ordered, and basically build a stack on the fly when we read the data in. I'm going to get rid of an input data set. I'm going to create a new test function for this video tutorial. I can define a min and max CDP range to work on, and I can also define the inlines that I want to work on. So in this case, we're basically creating a velocity field on every 80th inline. I can limit the maximum amount of time to display. I can read in a mute file if I have one, so I can select that from a drop-down list. It will navigate to where we are. I can, for instance, take the job for trace mute, select that. I can also, if I have a particular palette file for colors or color maps, I can read that in. I'm going to restore the default settings rather than going to pre-described settings. And also, as you'll see, we can also basically pick RM residual move out corrections in CVA. So basically read in pre-flattened gathers as output from our pre-STM modules, image K2T or image K3T, and rather than removing the NMO that the migration has applied to try and flatten or create flat gathers on output, we can basically create a field that is allows for an update of the already existing NMO that's on the data. So I will click OK. It will then come up with a parameter form that will ask me to define a seed function for the velocities. So I can input a trend file. So in this case, I can use the past one Bell's NMO, or if it's a completely new area to me and I have no idea what the velocities are, I could also just, or only a limited knowledge of what the velocities are, I could input type in a time velocity pair. I can also define where my first analysis CDP is, but I can leave those two blank, so I'll go OK. I'll then get a second parameter form, which is asking me for parameters for the stack part of the process, i.e. where it takes those CDP gathers I've got and stacks them up. So I'm going to apply a 70-degree stretch mute, or 70% stretch mute, sorry, a 500 millisecond AGC. I have the option to apply that 500 AGC before or after the stack, both before and after stack, or not at all. I'll stick with both. And I'm going to output this stack that's created to a new data set in my data area. So test stack for video and click OK. That means if I sort of have to exit out and come back in, I can always pick that stack up rather than starting from scratch again. So at the moment you can see it's going to take approximately 4 minutes to stack the data up on the sort of 8 or so inlines that we're going to process. So we'll let that run away. The progress bar will keep you informed as to how things are going. As you can see, the stacking process has nearly completed. We've got about 10-12 seconds left to go. Once that's completed, we'll basically get a graphic display window up, and it'll basically launch and show the stacks, and I'll draw those one after the other. Just drawing those. Default is to start semblance display up, so I'll click on a location to this full fold, and it's launched a semblance display. I can click on the gathers button and launch a gather display to sit alongside my semblance. As you can see on this, I have the options in terms of muting of no mute applied, as it is at the moment, stretch mute, or my pick mute, whichever I feel is best. So I'm probably going to go with stretch mute for the moment. At the moment, there are no velocities because I haven't picked. I have my rough trend, but I haven't actually picked anything at the moment. So we go down to where the water bottom is, put a pick in at about 1500 meters per second, and then gradually just pick down the semblance. And I can pick basically using the left mouse button. So I highlight the cursor where I want it, pick the left mouse button, should I want to move a pick or delete a pick, I can basically go up when it highlights red. If I click on that pick, it's deleted. If I reinstate that pick, as you can see, if I show again with a move, if I move the pick, you can see that the gather parameter, the gather panel updates on the fly as the pick moves. So once I'm happy with that location and that pick, I can then click on the next button and it'll move along the required amount that I've determined I want to pick on in terms of locations. It will basically extrapolate, interpolate the new function from existing ones, so it'll basically have extrapolated from my one function I have on this line. I can then go along and add picks where I feel they're necessary. I can move picks, or if I feel that a pick isn't required where it is, I can delete it and put a pick somewhere where I feel it's more important to have one. Again, once I'm happy with that semblance location, I can move on to the next one, and again, add more picks, move picks where I feel they're better, flattening the gather. Once I'm happy with that one, again, I can move on. So deriving and getting to a good, robust velocity field can be very quick and easy in Claritas once you're started and up and running. On more complex data sets or land data sets, or just if you have other preferred analysis functions available, you can add those in. So if I pull the stack section up to the front, and say I decided that variable velocity stacks would be useful, I can click on the VVS button and it will launch a VVS panel for me. Click on bells and it will show the current velocity trend. And again, we can pick on the VVS panel if we want to. So for instance, that pick, I might decide that I'd like to move it up to there. I feel that's a better stack response. Again, that one, and it will update the velocities on all the panels at that point. Also, whilst I'm working through analysing my velocities, I might decide that I'd like to see how my current picking and how my picking's going at the moment, how well that's improving the stack section. So I can click on the restack button. And what that will do is again take the input gather data set, take my current best velocity field and restack those lines with this new velocity field, extrapolated, interpolated as required. Again, much like the input, it'll take 3 or 4 minutes to do, but you'll get a progress meter come up on the screen to show you what's going on with an estimated completion time. And you can see that we have another additional 8 panels appended on the bottom, which will hold the new restacked lines when the stacking is completed. It's going to take about 5 minutes, so I will Let that run through. And as you can see, the restack has nearly completed. And once the restack's completed, the panels are redrawn. You can also see now that basically we have two rows with the inline numbering in there. So the top panel is our original stack for each line, and the bottom panel is our restacked data after the new improved velocity field. So we'll let it sort of redisplay the rest of them. So now I can toggle back and forwards between the original stack and the restacked version, and you can see how the stack is changing and hopefully showing some improvement with the new velocity field. Now, much like the other analysis panels, and I'll demonstrate this by moving back one location, this restack panel will now basically update on the fly as I move a velocity, but it will be localized around the area of that velocity, so it won't restack the entire data set. It will just literally restack the CDPs affected between the sort of locations you're currently at. So again, if I get rid of that pick that I've now moved out to a anomalous velocity and re-pick it where it should be, and that's demonstrating the power of the restack option. This means that we don't have to go out with the velocity field, stack the data up, review it in a separate application, identify areas where we feel the velocities are still suboptimal, and then go back into the velocity analysis package and tweak the picking. We can hopefully do it all in one application and optimize the picking to the best possible velocity field faster using the Claritas applications. I can, to make visualizing what's going on with the stacks a little easier, turn the velocity display off. I'll turn those on because it's useful to see where the locations are. I have some other analysis tools that I can use. I can also, rather than restacking the entire section, I can create mini stacks of localized areas. So I click on the mini stack button, it'll basically just sort of create, so in this case, the initial stack, previous new stack, and current best stack. I'll close that one down. I can also create near and far offset stack displays. I can create a time velocity display of the current CDP location to review. I can look at variable velocity gathers to see how well, and again pick on the VBG. So if I open that up, you can basically see that I've got a set of panels with the current location central CDP, and you can again put the things on there so you can basically track, say for this event, undercorrected, 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 getting flatter, flatter. Central function looking pretty flat. Past that central function, beginning to dip off, being overcorrected, so on and so forth, all the way across till sort of the higher panel numbers where that event is definitely very overcorrected and not very flat. Again, I'll close that down. I can also pick fourth order anisotropy parameters in the CVO package by clicking on the fourth order button. Now, if I've got no existing fourth order field, I can either specify an ETA field if I have one, or I can copy the second order to fourth order and start it off as a horizontal velocity approximation. That's what I'll do in this case. I'll click OK. I'll bring up another isovelocity contour display. So I have one of these for my second order velocity field and one for my fourth order velocity field. I will shrink that down for now. As you can see, it's another semblance style display. Initially, the default is to come up as a horizontal velocity picking. Just collapse that for the moment. A little shorter screen architecture on this computer. But basically, if I click Vels, I can show the second order velocities on there and a line showing where they sit, and you can then see how flat your data is using the second order. Haven't got a lot of apparent fourth order on this data, but I can also basically then just start tweaking the fourth order by moving it. It's moving it a lot. Don't want to move it quite that much, so I'll delete it. I can put a pick in, and then I can decide to correct the fourth order. So I can toggle back between no NMO applied on the gather, second order NMO applied, fourth order applied, no second, fourth, or I can just toggle back and forth between second and fourth, see the effect of my second order velocity field. I can also, if my preference is, I can also pick as an eta field rather than a horizontal velocity. So if I click on the view eta, it will convert that initial velocity field or analysis panel from horizontal to an eta, which is basically values around plus or minus 1 centered around 0. So there are options in how you wish or may want to pick your velocity field, whether it's eta or horizontal NMO. Show you some of the other functionality for. There is also a lot of functionality available within Claritas in terms, and the velocity analysis package, in terms of being able to tune how you look at the data. So at the moment I've gone through and shown you basically use of variable velocity semblance and stacks and variable velocity gathers. If I close down the semblance window, click on the params, select analysis calculation parameters. I can also change that from variable to a constant velocity approach. Click OK on that. Then click semblance onto the location. You can see that rather than having a constrained variable velocity semblance display, I've now got a constant velocity. So this can be particularly useful if you're starting on an area you've not got any knowledge of the velocities on. You don't want to basically limit what you're looking at, so you can allow it to basically be able to look at the raw data, see all the possible velocity trends, and hopefully sort of work out which is your primary trend, what are multiples, what may be diffraction energy, and start analysing and locking down onto a good velocity field earlier on. You can see also now that the constant velocity stacks, constant velocity gathers are available now rather than the variable velocity. And if we go back into the analysis calculation parameters, there's an awful lot of other stuff in here though, so we can define what sort of semblance display we're picking on, true semblance, stack, normalized stack, etc., etc. Define some super binning parameters for creating those semblance displays. We can define how we want the CVSs and CVGs, whether we want them overlaid or side-by-side displays, whichever is our preference. And we can also decide what type of mute we want to apply for the calculation. So it's worth remembering that in Claritas, none of the analysis windows are pre-computed. They are computed on the fly. So if you came in, started off on variable velocities and then got an indication that your velocity trend was off, you weren't flattening the data very effectively, or you were having to recompute the variable velocity semblance all the time, you could swap to using constant velocity displays instead. So I can also define where I want to go in terms of my locations. So I can define and make sure that it basically always moves to my nearest existing velocity function if there is one. I can basically make it so that I put new functions at a pointer location. So if I'm going through picking at my 1, 2 or 4 kilometer velocity analysis interval, and it becomes apparent that there's some geological complexity that would benefit from a finer grid around a small constrained area, I can then change it basically to put additional functions in based on the pointer. Click and drag mode is quite useful for land data, so I can effectively layer strip the data set and sort of concentrate on the first 500,000 milliseconds of data, use CVSs and CVGs, and really lock down on the velocity trends over those. Go across the stack, pick all the way across the top, then move that window down and go back across the other direction. And also tune the window behavior. So at the moment on this data set, I've got it updating all the analysis windows on the fly as I make changes. If you're on a lower spec computer, it can sometimes be useful to be able to turn that functionality off. So update displays, we can change that to no, and so it won't basically update displays on the fly. And we can define an autosave increment. So at the moment, basically every time you make a pick, it's saved into the relevant .nmo or ETA file. Again, slow computers, it might be worthwhile just saying I want to save every 100 picks or so and do it that way. So basically the thing to realize with CV8 is there's an immense amount of functionality in there. You can tune your velocity analysis to optimize your data or how you like to pick. It's not sort of set in stone as to how it's to be managed or done. That flexibility should allow you to basically resolve to the perfect or an optimal velocity field very quickly and very efficiently. Thank you for watching this video, and any questions, please contact claritas.sales or claritas.support@gns.cri.nz. Thank you very much.